This is an explanation of the 18.2 assessment that we had this past week. Again, I'm using the same worksheet, worksheet number 1. The first question you had on your quiz was a first order reaction has an initial reaction rate of 2.4 moles per liter second. What is the rate when 1/8 of the starting materials remain? Well, first of all, you have to understand what a first order reaction means. It means the rate is proportional to the concentration of the reactant. And so what this is saying is if you double the rate, if you double the reactant, you double the rate. Well, and vice versa. So if you have 1/8 of the reactant, you're going to have 1/8 of the rate. So all you had to do is take 1/8 of the 2.4 mole reaction rate, and the answer you got was 0.3 moles per liter second. By the way, with this value of K, this is one area of chemistry where we don't use units or don't have to use units because they really don't help us. So the K value constants, it's one of the only things in all of chemistry that I don't use units for. Okay, and then the second question was, it has been experimentally determined that the rate law for the reaction between mercury 2 chloride and sodium oxalate is third order overall and first order with respect to mercury chloride. Write the rate law for this reaction. So they showed you the reaction. Well, the rate is equal to K times the concentration of the mercury chloride and then times the concentration of the other reactant. Now it told you it was first order with respect to mercury chloride. So that gave you the order here. And that it was third order overall. So that means that this exponent plus the exponent you don't know have to add to be 3 if it's third order overall. So in order for it to add to 3, the power here for x would be 2. Okay, because 1 plus 2 would give you a third order overall reaction. Okay, and then in number 3, we've got a combination reaction gave the following data. What's the rate law for this reaction? J plus M made M, and they gave you a table of data. We know the rate, the form of the rate law has to be rate equals K times the concentration of J to a power we'll call X times the concentration of K to a power we'll call Y. And then they give you a table of data, and the first 2 experiments, K is being held constant and J is doubled. So, and we also have a change in the rate. Now you can probably just eyeball this and say, gosh, if the rate doubled and the concentration of J doubled, that must mean it's first order. But let's do the arithmetic of how you would figure that out if you can't just eyeball it. So I always take the bigger one, the 0.16, divided by the 0.08 from here, and then I take the reactant that is changing. In this case, J is changing. 0.6 divided by 0.3, and I always take the big one divided by the little one just because it makes the arithmetic a little bit easier. And the power of this, we said that J was to the x power, so I made this to the x power. So 2 equals 2 to the x, so x must be 1. And then for Y, I can also eyeball this. If the concentration of K was cut in half and the rate was also cut in half, I can tell without even doing any math that it must be a first order reaction. But let's go ahead and do the math. If I divide the bigger rate by the littler one here, I get 0.16 divided by 0.08, and then the concentration of K, that's 0.5, divided by the concentration that is I think I've made a mistake here. Let's see. 0.5 divided, this should be 0.5. 0.5 here. And this should be 0.25. And the 2 rates were right here. 0.16 divided by 0.08 is 2. 0.5 divided by 0.25 is also 2. So 2 equals 2 to the y power. Y must be 1. So the rate law for this was rate equals K times J to the first power, the concentration of K to the first power as well. So it's first order in each one of these reactants, which makes it second order overall. And then, let's see, the fourth question you had was, iodide ion catalyzes the decomposition of hydrogen peroxide. The reaction is first order in hydrogen peroxide. What is the value of the rate constant K if the initial rate is 0.00842 moles per liter seconds? And then they gave you the initial concentration of H2O2 is 0.5 moles per liter. So this is the reaction. There's only one reactant. They told you it was first order, which gives you the rate law. For a first order reaction, rate is equal to K times the concentration of the one reactant to the first power. So all you have to do is take this information. They gave you the rate, plug it in here. They gave you the concentration of H2O2, plug it in here, and find the value of K. You know I like to solve for my variable first, so doing a little bit of algebra, K is equal to rate over the concentration of H2O2. Plug in the rate, the concentration of H2O2, and you get that K is equal to 0.0168. And again, with K values, we don't worry about units. Number 5 says a proposed reaction mechanism has two intermediates. How many elementary reactions are in this mechanism? Well, if there are two intermediates, that must mean, if we make a quick little energy diagram, that there are two valleys. So one valley and two valleys. Okay, so those would be the two intermediates, two valleys. So that would be a 1, 2, 3 step reaction. In order to have two intermediates, it has to be 3 elementary reactions, or a 3-step reaction. And then number 6, the reaction A plus B makes C is first order in A and B, second order overall. So I want you to complete the following table. So this is a little bit backwards from the way we normally do these. They're giving you the rate order. So rate is equal to K. It says it's first order in A, so we have a 1 on the concentration of A and a 1 power for the concentration of B. Now, this is one also where you don't really need to do the math. If you just look at the data and say, okay, B is changing here. If you know that it's first order, that means that the rate is directly proportional to each one of these reactants. So if the rate doubled, that must mean that the concentration of the reactant B doubled. Okay. But if we want to show how we would do that mathematically, we take this rate divided by this rate, and we could call the number here that we don't know x, and take x over 0.5, that's what I'm putting here, and that's to the first power. And so if you solve for x, you get x is equal to 1. But again, you can, just by understanding what a first order reaction means, you can get that number from the data as well. So let's see about the next thing you had to fill in the table was here. And so the other reactant, A, was being cut in half, went from 0.5 to 0.25, so it was cut in half. If this is a first order reaction, meaning that the rate is directly proportional to the concentration of A, then if you cut this concentration in half, then the rate must cut in half. Again, just to show how we would do that mathematically, if we call this number here x, 0.04 over x equals the concentration's changing, 0.5 over 0.25 to the first power, because we know it's first order, and when we solve for x, we get x is 0.02. Okay, so let's see. Then the next question on your quiz was using another little worksheet. Your quiz wasn't exactly this way. It gave you choices rather than have you draw a diagram. But this question says, draw a diagram for a reaction with 2 elementary steps. 2 elementary steps tells you 2 humps. Okay, the first step is slow and has an activation energy of 100 kilojoules per mole. The second step is fast. So what that means is if the first step is slow, it must have the higher hump than the second step. Okay, and this activation energy of 100 kilojoules per mole means that from the energy of the reactants that you start with to the top of the hump, that distance has to be 100 units or joules per mole here. Then it says the reaction has a heat of reaction of plus 20 kilojoules per mole. That tells you it's endothermic. And it wants to know what the activation energy is of the reverse reaction. Well, first of all, let's figure out how we would make delta H of 20 kilojoules per mole. That means the energy of the products from the energy of the reactants, that difference, that's your heat of reaction, delta H. And if it's positive, that means it's an endothermic reaction, so the products gained energy, they have more energy than the reactants, by the 20 joules. So this drawing is showing that this reaction has a heat of reaction of positive 20 kilojoules. Okay, and then it says mark the activated complexes and intermediates. Well, top of each peak is an activated complex. Now, just because each of these is an activated complex, the activation energy is always the energy required to get over the highest hump. Because if you can get over the highest hump, then getting over this one's no trouble. Now, the intermediate is the valley, and there's only one valley here between the two humps, so this would be the intermediate. Now, question on this worksheet says show what a catalyst does to this reaction. And you've got a hint here, it only changes one elementary step. The catalyst would just lower the height of this hump here. That's what a catalyst would do, making the reaction go. It would make this slower step would go faster, making the overall reaction go faster. And then, let's see, there was another question on your quiz. The condensation of acetic acid with methanol to form methyl acetate in water is catalyzed by HCl. Okay, here's the reaction, and now I rewrote this reaction to make it look a little bit easier to follow. In the first step of this reaction, you have these two reactants reacting to form this intermediate. It looks like I left off a reactant here. I should have another reactant in here. But these two reactants react to form this intermediate. And in the next step of this reaction, this intermediate reacts to form these products. So it asks you to write the formula for the reaction intermediate. Well, first of all, how many elementary steps? Well, it was 2 steps. One step to make this intermediate, and then another step for that intermediate reacted to form these products. So it's a 2-step reaction. The formula for the intermediate is this formula right here. And then the rate law. Actually, we can only say the form of the rate law is the rate of this reaction is K times the concentration of the first reactant to the X power, the concentration of the second reactant to the Y power. The reason I say the form of the rate law is we don't have the data to be able to say what the values of X and Y are. And then the last thing that was on your quiz for 18.2 was some vocabulary. Now, not all of these terms are on there. Activation energy was a term that was on your quiz. Activation energy is number 4 here, the minimum energy colliding particles must have in order to react. And then F, activated complex. The activated complex is the arrangement of atoms at the peak of that activation energy barrier. It's the arrangement of the atoms when you're up there at the peak of the activation energy barrier. And then the last one we had was a first order reaction. And a first order reaction is a reaction in which the rate is directly proportional to the concentration of one of the reactants.